Students, in last class we have studied preparation of aldehydes and two methods to prepare ketones. So in the preparation of aldehydes, the aromatic aldehydes are prepared by two methods. One is from toluene. That reaction is called Aldehyde reaction. So oxidation of toluene with chromyl chloride in carbon disulfide gives benzaldehyde. Benzaldehyde can also be prepared by Gattermann-Koch reaction. So in Gattermann-Koch reaction, benzene is heated with carbon monoxide and HCl in presence of anhydrous AlCl3. Little some cuprous salt like cuprous chloride is added, along with the AlCl3. And in preparation of ketones, we are studied preparation of ketone from dialkyl cadmium and acyl chloride, that is RCOCl. Second method, ketone can also be prepared by Prelkraft reaction. So in Prelkraft reaction, benzene is treated with acid chloride, that is RCOCl in presence of anhydrous AlCl3. So product is ketone. For example, to prepare acetophenone, so benzene is treated with styrene chloride in presence of anhydrous aluminum chloride. So this is Prelkraft reaction. Even ketone can also be obtained by using Grignard reagent. So in a Grignard reagent reaction for preparation of ketone, nitrite, that is RCN, is treated with Grignard reagent to form addition product, and that on hydrolysis gives ketone. So it is from nitrite or preparation of ketone from nitrite or from Grignard reagent. So here nitrite is treated with Grignard reagent. Treated with Grignard reagent. Grignard reagent to form addition product. To form addition product, which on hydrolysis or which on treating with water, this hydrolysis also treating with water gives ketone. So this is the one more method you are using to prepare ketone. We know the formula for nitrite, RC triple bond N. Grignard reagent, I am writing R dash MgX, alkyl magnesium halide. Well, we know this R dash or R is negatively charged because magnesium is electropositive, so it carries positive charge, MgX. So R attack on this carbon as the nitrogen is more electronegative, a pi electron pair move towards the nitrogen. So MgX attached to this one. The product is R, C R dash, then double bond N MgX. So this are treated with water, or when it is hydrolyzed, you are getting R, C double bond O, R dash, and then it is MgX OH. Actually NH2 is formed, MgX NH2 is formed, which further react with water to change into OH, and then one more is NH3. Example CH3 C triple bond N. It's a nitrile. Number of carbon atoms are 2, so it is ethane nitrile. Plus I am writing C2H5 MgCl. We know it is called ethyl magnesium chloride. Ethyl magnesium chloride. So it forms addition product. As we know, in case of reaction of Grignard reagent, C2H5 or R attached to the carbon of the double bond or triple bond. So it's a C2H5, then double bond N, MgC. So this on hydrolysis. We are getting CH3, C double bond O, C2H5, then it's MgClOH and NH3. So name of this product is or it's ethyl methyl ketone, and IUPAC name of this one is total number of carbon atoms are 1, 2, 3, 4. So it is butanol. There is no possibility of 1 butanol, 2 butanol or 3 butanol, because when the structure is expanded, we are getting this type of structure CH3 C double bond to CH2 CH3. So if I write C double bond on this carbon or on this carbon, it is nothing but the second carbon itself. So no need to write the number. It's butanol. 1, 2, 3, 4 carbons. It is butanol. So this is about preparation of aldehydes and ketones. Well, in the physical properties of aldehydes and ketones, as we know, this bond is slightly polar, C double bond OC, then or C double bond OCH like this. It's a slightly polar. Well, why it's a polar? Because we know oxygen is electronegative and it's get partial negative charge, this will get partial positive charge. But in case of hydrocarbon, the polarity is negligible. Hydrocarbons are non-polar compounds. They are slightly, aldehydes and ketones are slightly polar. What happens if there is a polar character? The association of molecules takes place, or molecular association takes place. Due to that polar nature, there is attraction between the polar, negative and positive part of one molecule with the another molecule. So slight association takes place. When there is association or interaction, we know the boiling point is greater compared to without polar character. So aldehydes and ketones are having greater boiling point or more boiling point than the non-polar hydrocarbons and also less polar ethers of comparable molecular mass. Why the boiling point is more? Due to association. Why there is association? Due to slight polar nature of C double bond O bond. So this is about boiling point, or sometimes it is a solid melting point is also greater. Second point about solubility. Well, we have some polar character in case of aldehydes and ketones. That means the aldehydes and ketones with few members of carbon or less carbon atoms are soluble in water due to hydrogen bonding with water. Why they are soluble? Due to hydrogen bonding with water. So which type of aldehydes and ketones? Aldehydes and ketones are having low molecular mass or less number of carbon atoms. In other words, lower members of aldehydes and ketones, example formaldehyde in aldehyde, acetaldehyde, then ketone is acetone, are soluble in water due to hydrogen bonding with water. As the number of carbon atom increases or hydrophobic character increases, solubility decreases. So, aldehydes and ketones are soluble in non-polar solvent also, especially the higher members are soluble in non-polar solvent. So, this is about physical properties. So, remember in physical properties, two things are important. One is about boiling point or melting point, and second one is about solubility. So, in physical properties, it is number one, boiling point, BPT, boiling point. BPT of aldehydes and ketones are greater than hydrocarbons and ethers. Hydrocarbons and ethers of comparable molecular mass. Due to polar nature of aldehydes and ketones. So what happens if there is a polar nature? Association of molecule takes place. Molecular association takes place, boiling point increases. But less than alcohols of comparable molecular mass. Due to intermolecular hydrogen bonding. In alcohol. So this is the first physical properties. This is a boiling point. Second one is solubility. Lower members of aldehydes are soluble in water due to hydrogen bonding with water. H bonding with water. Solubility decreases. With increasing number of carbon atoms. So this is called, it is due to hydrophobic nature. Means hate water, cannot mix with the water. That's that's called hydrophobic nature. Well, these are the physical properties of aldehydes and ketones. Well, let us discuss about chemical properties of aldehydes and ketones. So, some of the properties of aldehydes and ketones are similar. For example, nucleophilic addition reaction, reaction with alcohol, nucleophilic addition and elimination reaction. So, all these properties are similar. It is due to C double bond O group. As we know, both aldehydes and ketones contain C double bond O group. So, these are the properties due to C double bond O or carbon group. Well, now let us discuss some chemical properties. Chemical properties. So, in chemical properties, it is nucleophilic addition reaction. Properties. Number 1, nucleophilic addition reaction. Nucleophilic addition reaction. So we know nucleophiles. Nucleophiles means they have affinity towards the positive center. Generally, nucleophiles are negatively charged. In other words, you may say they are electron rich. And in case of carbonyl of aldehyde and ketone, oxygen is more electronegative, so electron transfer towards the oxygen. Oxygen carry negative charge and carbon carry positive charge. Nucleophile attack, that is, which has affinity for the positive center, so nucleophile attack on the carbon. So that's the nucleophilic addition reaction. So nucleophilic addition reaction, number 1, A you can write, addition of HCl. Let us discuss about mechanism of addition of HCl. That is, base catalyzed addition of HCl to the aldehyde or ketone. So in mechanism, first it is a formation of nucleophile, that is formation of Cn minus. So how that Cn minus is formed from HCl? That means you have to remove the H. Hydrocyanic acid HCl means there is a peebly dissociation of HCl. So means the H or H plus is to remove. Say acid, you have to remove H plus from HCl, that means you have to use base. So in presence of base, Cn minus is formed. Well, let us discuss about mechanism. Mechanism of addition of HCl. So HCl in presence of base gives Cn minus. So it is formation of nucleophile or generation of nucleophile. Generation of nucleophile Cn minus. HCl interact with the base or base removes that H plus to give nucleophile Cn minus. Second, big attack of Cn minus on carbon of C double bond O. I am writing this C double bond O, that is aldehyde or ketone. So I am writing C double bond O, then so we have the 2 more valency for this carbon. It may be hydrogen or it may be sub-alkyl or aryl. So I am writing simple aldehyde RH. Or instead, without writing RH also, we can show the mechanism. It's a Cn minus. Well, the Cn minus attack on this carbon in perpendicular to this plane. So carbon is sp2 hybridized. It's a trigonal planar. Trigonal planar. As we know, It's sp2, carbon is sp2 hybridized. So whenever we have sp2 hybridization, we know the geometry, trigonal planar, it's a planar. Cn minus attack on the carbon in the direction perpendicular to the plane. Suppose if we have C here, these are the two bonds. For ketone it's R and R dash, for aldehyde it's R and H, C double bond is here, this is the plane, Cn minus attack perpendicular to the plane. To form intermediate, so you are getting this product, intermediate product, I am writing here Cn minus, changes to Cn now, it is double bond O, and here we have O minus, and because of shifting of this electron move here, so it's a O minus, it's intermediate, it is intermediate, and its geometry is tetrahedral, it's a tetrahedral, and this carbon is sp3 hybridized. This is sp3. Carbon is sp3 hybridized. Now this one accept proton. It accept proton to give the final product CCN OH. Then it may be H or it may be R. Okay, so this is about mechanism. First one, generation of nucleophiles, Cn minus, just you write equation, this much is sufficient. And then attack of Cn minus on carbon of C double bond O. When it is sp2, hybridized, it's more electronegative, electron move towards the oxygen, so it becomes negative charge and this carbon is positive. So the Cn minus attack on this one to give the intermediate, it's intermediate, tetrahedral intermediate. Then it accepts the H plus to give the final product cyanohydride called cyanohydride. So both aldehydes and ketones react with hydrogen cyanide to give cyanohydride. So this is the mechanism. Remember the mechanism. Two steps are there. Simple equation. Generation of nucleophile. Second, attack of the nucleophile. So here both aldehydes and ketones react with HCN to form additional product cyanohydride. Both aldehydes and ketones react with HCN, to give cyanohydride. So aldehyde R C double bond OH plus HCN. So the product is this R C OH CN and H. So this is called cyanohydride or aldehyde cyanohydride. Aldehyde cyanohydride. Example CH3 C double bond OH, when it is called ethanol or acetaldehyde, or it's also called ethanol plus HCl. So the product is CH3C, then we have OH, Cn and H. So it is acetaldehyde cyanohydride. Additional product is acetaldehyde cyanohydride. Acetaldehyde cyanohydride. I am writing for ketone R C double bond O R dash. It's a ketone. So ketone react with HCl to form ketone cyanohydride. So we have RCOH Cl Aldehydes. It is called ketone cyanohydride. Ketone cyanohydride. You may write any example. I am writing acetophenone. Example, acetophenone. We know the formula for acetophenone. C6H5 C double bond OCH3. It's a bulky group plus HCl plus HCl. It gives acetophenone cyanohydride. Acetophenone cyanohydride. This is acetophenone. Acetophenone. Product is acetophenone cyanohydride. Acetophenone cyanohydride. Acetophenone cyanohydride. This is the reaction of HCl with aldehydes or ketones. Well, afterwards, aldehydes and ketones also form addition product with sodium bisulfite, and the product is called sodium bisulfite compound. Remember, in case of sodium bisulfite, NaHSO3 is a large group. NaHSO3 is not like HCl. HCl is small, so it can attack on the carbonyl without hindrance, means with even less hindrance in case of aldehydes and ketones or HCl. Because of small group, it can attack on both aldehydes and ketones, whatever the group attached to the C double bond group. For example, this is bulky group, but HCl add on this due to small size of HCl. Suppose if it's sodium bisulfite, NaHSO3, then what happens? In case of NaHSO3, the bulky group of ketones do not get interact with the sodium bisulfite due to steric hindrance. So B, addition of NaHSO3. Addition of NaHSO3. So both aldehydes and ketones react with NaHSO3 to give with NaHSO3 to give bisulfite compound. Bisulfite compound. So here aldehyde plus NaHSO3 plus NaHSO3. The product is C double bond O changes into OH, and here we have SO3 Na. SO3 Na. Aldehyde sodium bisulfite compound. Aldehyde sodium bisulfite or simple bisulfite compound. Aldehyde bisulfite sodium bisulfite would. So sodium bisulfite compound or simple, it is bisulfite compound. NaHSO3. The product is SO3 Na OH. So aldehyde bisulfite compound. Bisulfite compound. For ketones, only lower members of ketones, only lower members of ketones react with NaHSO3, to give OH. It is NaMnSO3 Na. Product is ketone bisulfite compound. Ketone bisulfite compound. Example. So, in addition reaction of sodium bisulfite, both aldehydes and ketones ketones react with sodium bisulfite to give bisulfite compound. So sodium bisulfite formula, sulfite is SO3. Sodium, bi means H, or sodium nitrogen sulfite it's also called. So aldehyde sodium bisulfite gives aldehyde bisulfite compound. It's also called aldehyde sodium bisulfite compound. Example, when we have acetaldehyde, then product formed is acetaldehyde bisulfite compound. Remember, here the actual mechanism is CH3, C double bond O, or you may write in general R, C double bond OH or R dash. I am writing H plus NHSO3. So addition takes place. We know it's a more electronegative, pi electron here. Then it's SO3 means H, Na links to here. Okay, because of positive charge, it links here R, C, O, N, A, SO3, then H, and I am writing here because you may get confused here. You may write here or there because all bonds are equal. So it's a SO3H. As we know, this is strong acid, SO3 compared to oxygen. So here there is simple rearrangement takes place. Instead of Na, now Na move here and hydrogen to the H. So we are getting this product. First the product is different. Product is like this. Then we have rearrangement. Rearrangement. You are getting this product R, C, OH, H, SO3, N. Well, it may be aldehyde or ketone. So aldehyde bisulfite compound, acetaldehyde bisulfite compound. In case of ketone, ketone bisulfite compound. In case of acetone, it's a acetone bisulfite compound. So higher members of ketones, for example acetophenone or other higher ketones, do not form addition reaction sodium bisulfite. Why it is so? This is because sodium bisulfite is bulky, large group, so it cannot attack easily on this carbon when we are bulky group. In other words, in terms of the reactivity of aldehydes and ketones, you may say aldehydes are more reactive towards the addition reaction compared to ketones. It is due to two reasons. One is due to the presence of two large or bulky group around the double bonded C double bond O or carbonyl group. There is some hindrance. Second point, it is due to the electronic effect. So electronic effect is greater in case of ketones compared to aldehydes. So these are the two reasons that explains why aldehydes are more reactive compared to ketones for the nucleophilic addition reaction. Benzaldehyde is less reactive again. Why benzaldehyde is less reactive? Due to the resonance structure. So we know the formula for benzaldehyde. It's the formula of benzaldehyde. C double bond OH. There is a movement of this electron, and when it gets the plus charge, this will get negative charge. There is a movement of this electron also. 5 electrons, and the structure changes to like this. It is a C, then O minus, and afterwards double bond. So structure changes like this. That means there is no positive charge on this carbon, and there is no electrophilic center. There is no electrophilic center on this carbon, and hence even benzaldehyde is also less reactive towards the nucleophilic addition reaction.